You're listening to the Skeptics Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptics Guide to the Universe. Today is Thursday, December 8th, 2022, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Jay Novella.
Hey, guys.
Evan Bernstein.
Good evening, folks.
And we have a guest rogue this week, Brian Newell. Brian, welcome to the SGU.
Thank you so much. It's so fun to be here. Can't wait to talk to y'all.
Brian, why are you here, by the way?
How'd you get this number?
I am just a long time listener, and I made my way through the entire back catalog a long time ago, and now just an avid weekly listener and contributor to the Patreon. So I'm all in for skepticism.
So aren't you the guy who won our special Star Trek phaser giveaway?
This is true, yes. I did, and I think based on the Patreon level, it seemed like it was. I had a good chance going into it, but yeah, no, it was a big surprise.
And then you decided you had nothing to do with it.
He couldn't get his fingerprints on it for technical reasons.
Well, yeah, I mean, to be fair, I was giving Jay plenty of time to come around to figuring out how the heck to get it out of there. And then I think I realized that as much as I love Star Trek, I wanted it to go to some place where it could be loved completely. I'm more of a sort of dabbler. I'm a Star Trek dabbler. I sort of jump in and out. And so if it could go to a place where it could be even better loved, I'm happy to donate it there.
Well, it's a commitment. I mean, this is a huge prop. I honestly don't have a good space for it. That's
gotta
how big
have
it
a
is.
Man cave, man.
Yeah, well, I do. I mean, I have my office. Because I want it mounted on the wall, and I've already used that space for all my other stuff. So I have
take down one of your lightsabers.
I have 3 long rifle styled blaster weapons, right? Including that I don't have any place to put in my office, and they're just sitting here.
Only 2 of them work.
Very accessible by my children, I might add.
Oh, dangerous.
So I totally understand, Brian. You can't just have one of these things. You have to really be equipped to own it and have it live somewhere.
Yeah, totally. So I don't know. I mean, look, if it ever showed up on my doorstep, I wouldn't turn it away. But I think if we can find a place that's great for it, especially I know you guys at one point talked about some kind of Star Trek. Or some kind of, whether it's in a studio space or something like that.
Yeah, we're still working on having an event at the Star Trek Museum.
Ooh.
But we'll recycle it to make sure it gets a good home. So I told some of you guys,
yeah,
I now have a radioactive cat.
Yeah, you did.
Mm-hmm. You did.
Legit.
It's legitimately radioactive.
His name is
Schrodinger. It's so radioactive that it could hurt you if you pet it.
Yeah.
And he put it in a box, and then he closed the lid.
So my cat has hyperthyroidism. It's apparently very common in this breed of cats. It's basically a tumor, He was losing weight, and we could tell something was off. And this is now going back maybe 6 months. We brought him in. He was hyperthyroid. And they gave us 2 options. They said we could either inject him with radioactive iodine or you can give him a pill. And the medication was pretty cheap. We were thinking about doing the one-time procedure, but they also said, and he's got something in his lung. They did a chest x-ray. And he's kind of an oldish cat. He's 11 years old. So we said, well, maybe we'll just treat him with the medication for a couple of months until we see what this lung thing is,
Yeah.
Turns out that was nothing. It also turns out that the medication that we were giving him wasn't really working, and it gave him anemia. Oh. So he started to get really sick, he couldn't walk anymore. Ooh. His head was dropping, and he was slapping the ground with his feet, very uncat-like gait, very noisy and clumsy. Was tripping when he was trying to jump on something. So we brought him in again and said, the medication is not working. So we pretty much have no choice now but to go with the radio cat option. We brought him in a couple of days ago. It's like the procedure. It takes 2 seconds. They just inject him subcutaneously, under the skin, with radioactive iodine. The iodine gets absorbed by thyroid tissue, right? And apparently, it kills the thyroid tumor, but doesn't kill the healthy thyroid. I guess because the concentration isn't enough.
That's convenient.
Yeah. So they said
wish more tumors react to that.
One shot and they're cured, basically. And it works almost every time. Apparently, occasionally it takes a second shot, but there's like a 98 whatever % chance it works with a single shot. And that's it. You're done. No more meds, nothing. Just completely cured. So he's in the clinic because he's too radioactive to come home for like the first 4 days. I'm going to pick him up tomorrow, and then we have to be on radioactivity protocol for 2 weeks.
Oh my gosh!
Which means that we can't be
hazmat.
We can't be close to him for more than like 30 minutes a day.
Wow.
Now, what would happen if you did?
Well, you're exceeding your, safe exposure to radiation. So it increases your risk of cancer and stuff.
You should get one of those radiation badges and see where you're at.
So we're basically going to keep him in the loft, like on the 3rd floor, and just feed him up there and leave him up there.
Yeah.
But we also we had to buy this special flushable kitty litter because we can't throw it out into the garbage. We have to flush it down. Yeah.
It'll dissolve in the water of the...
I don't know.
Well, that'll be good for the alligators down there.
Right, got these mutant radioactive alligators. Yeah, it's very interesting. The whole thing,
I just find it amazing that they're giving him a certain level of radiation that it absolutely is affecting the rest of his body, but he won't live long enough for that radiation to have a long-term effect on him because he doesn't have a long-term lifespan like humans do.
Right. And we have another cat in the house. They said, yeah, they don't worry about it. They're fine. They just don't live long enough.
I see what you're saying. Right? Yeah.
Yeah,
of course.
But what if it was a kitten?
I get it. They didn't even ask about that. Both cats are like 11 years old, so they're don't have that.
So if you're like 75, they would say, yeah, you could play with the cat. Don't worry about it.
Well, for people, they never say that. They'll never say, I get exposed to radiation. But
could they?
But here's what they do, is they have even lower, thresholds in kids, right? So if you're a kid, we're especially careful about exposure to radiation because you have a much longer life ahead of you, and the risk is greater that you can get a side effect from that. So, if you're 50, 60, we don't worry too much about giving you a CAT scan, or doing x-rays. But if you're a kid, you have to think very carefully about every single time you expose them to radiation diagnostically because the cumulative risk is much greater. So it's not that they say it's okay in old people. It's more that it's just you have to be especially careful in young people.
Yeah,
but,
makes sense.
If you're 90, sure, roll the dice. I mean, it's probably not going to do, whatever.
I always click over to the idea, we're lucky that incredibly smart people figured out how to use radiation to our benefit.
Mm-hmm.
It is important. We need it. If you need an x-ray, you need it. You know what I mean? We use it. It's an important thing. If you need to get something irradiated, which happens in people as well, we're using this incredible thing, this power of the universe, whatever the hell it is. It's
it could cure or destroy radioactivity.
Yeah. Yep.
Absolutely.
I always think of Curie and everyone
Oh,
in the early days, la 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 la,
Oh,
messing
gosh.
with this stuff, la la. Oh boy, not good idea. I mean, how would you know?
When your jaw falls out.
Well, that literally happened. There was a guy who was like a bodybuilder, and he was recruited as a spokesperson for a radioactive tonic, like radium. People did that. They had
radium drinks.
Yeah, radium drinks. You can get a pitcher made out of radium, and you put water in there, leave it overnight, and it gets radioactive, and then you drink it. And it was supposed to give you energy, right? Because it was the newfangled sciencey thing, radioactivity. And this guy would drink it all the time, on the carnival circuit or whatever, and eventually, literally his jaw fell off. he just
Ouch.
destroyed his tissue, not just like getting cancer, but like literally caused necrosis of his tissue.
Yikes.
Yeah.
Brutal.
Very nasty. But radioactive tonics didn't go away until they were banned by the FDA.
Isn't that remarkable?
Yeah, it took.
Remarkable.
It didn't go away because they didn't work and because they were dangerous. They went away because they were banned legally. That was it. Unbelievable.
I totally believe it.
All right, well, let's get on to some news items. We're going to start with the Square Kilometer Array. You guys know what this is? Brian, are you into radio astronomy?
I mean, yes, of course, yes, but I've not heard of this. I've not heard of this topic.
Yeah, the Square Kilometer Array is a new radio telescope. It's going to be the largest in the world. This was originally conceived of in 1991, more than 30 years ago. That's how, and construction is just beginning.
Oh my gosh, Hubble went up the year before that.
Yeah.
Holy moly.
This is like going to be a 40, 50-year project before this thing is completed from idea
That
to
long.
completion. Yeah.
Yikes. 2 generations.
All right, so there's 2 components to it. There's the Square Kilometer Array, or SKA low, for low frequency. That's being built in Australia. Now, this doesn't have the typical radio dishes. This has antenna that look more like a wireframe Christmas tree, right? About 2 meters tall. You know, with like you would think of it, if you saw it on top of a house, you would think it was a TV antenna. You know what I mean? A little bit big, but the ultimate goal is to build 500 arrays, each with 256 antenna, for a total of 131,000 antenna. That's the low frequency array. That'll be operating in the 50 megahertz to 350 megahertz range. Then there's the SKA mid. That's being built in South Africa, and that will be comprised of 197 dishes, sensitive between 350 and 15.4 gigahertz.
How big? What's the diameter of those?
I don't know what the diameter of the dishes themselves are. It's 197 total dishes. The 2 of them will be linked together, and obviously over the internet, and they're going to be controlled in the UK. Again, over the internet. So that's where the most of the computer processing power is going to be, and the throughput, like the actual amount of data going around this the network for these two radio astronomy arrays, is greater than the current traffic of the internet.
What?
Yeah,
So how many quotabytes?
I don't know how many quotabytes.
Well done, Bob. Way to use the new measurements right off the bat.
All right. So why do you link radio dishes together, Evan? Do you know this?
Why? Well, to increase the power.
Yeah, I mean, power's a vague term, but it does increase something about them.
Sensitivity?
Nope, not the sense. Good guess, but no. Not the resolution and the precision. So
Interferometry.
yeah, to use interferometry. So basically, if you have 2 radio dishes 1 mile apart and they're linked together, and you use radio interferometry to sort of combine the signals of the 2, it has the resolution of a dish with a 1 mile diameter, right? But it doesn't have the sensitivity, because that's more about the collecting area, right? That's why you need a lot of dishes. Otherwise, you could just have 2 dishes 100 miles apart, and you have a 100-mile diameter radio dish. It simulates a dish of 100 miles, but not the sensitivity. You're still only collecting a very small amount of energy. Mm-hmm. If you want the same sensitivity, you would have to literally have a dish that big. But that's why you have, like in this one, you're going to have 197 dishes. So, the total...
Best of both worlds.
Yeah, the total area will enable you, to detect... to have a very, very high resolution, and the number of dishes will give you great sensitivity. But also, Bob, you're familiar with the Very Large Array in New Mexico.
Oh, yeah.
So that is another, very large array of radio dishes. Those dishes are on rails, and they move them in and out. So why would you do that? Why would you bring dishes that are farther out and bring them in? You're just losing resolution.
Depends what you want.
It depends on what you're looking at, right? So when you move them closer, they get more precise. Like you'll get I don't know if it correlates to this, but I think it gets like a sharper image. right? So if you don't need the maximal resolution at low wavelengths, then you can bring them closer together to get a better image. So they move them in and out a few times a year, depending on what they're going to be looking at over the next few months.
That's so cool.
Yeah.
Love it.
Neat.
So what can we do with this now upcoming largest array in the world? And they call it the square kilometer array because when it's complete, I'm not sure which one, but one of the components, I think it might be the Australia component, will have a square kilometer of radio telescopes. So they're both in the southern hemisphere for a reason, because the southern hemisphere has the best view of the Milky Way galaxy.
Sure does. We've seen it.
Yeah. Yep.
I love the sky down there.
I miss it.
I fell in love with it.
It is awesome.
The crazy thing is, though, we were down there 3 times, and we only got a good view of the sky once.
One night was totally clear.
And
only
we
one.
had to go out of our way to do it. We had to drive away from a city to get away from all the light pollution in order to get a decent view of the nighttime sky down there.
It was so cool.
It was
We went to a
gorgeous.
specific observatory, specifically like at 1 a.m. or worse, for a thing that we just we're all excited about. We get there and it was crazy.
Cloudy.
Of course, because I was there, it was crazy cloudy. Didn't see anything. It was still a wonderful night, but man, it was so hard not to go outside and look and see what we wanted to see and what we had just learned about because they taught us about it, which was fascinating. But when we went a few days later, though, it was even better because then I was more, my knowledge was more refreshed about what the sky was all about and this, Southern Cross and all of that, Magellanic Clouds,
Yes.
and so you can immediately identify everything, the big stuff. It's it was magical, it really was.
So this telescope could see, farther and deeper into the universe than any other radio telescope previously. And it'll be good for looking at imaging neutral hydrogen in the early universe, imaging black holes, pulsars, and cosmic magnetism. Additionally, it'll be good for detecting fast radio bursts. Getting
nice.
more detail about them. So it's not just detecting them, it's also being able to analyze them in greater precision and detail.
Yeah.
And it will be used...
Come on, SETI.
SETI.
Come on, yes.
SETI,
for SETI. So the interesting thing is when SETI is the search for extraterrestrial intelligence, which mostly uses radio astronomy to basically look for radio signals from that may be being sent our way from alien, intelligent, technological civilizations. The original SETI projects basically got radio dishes dedicated to doing SETI observations, but that turned out to be not financially sustainable, right? You would need sustained funding to just look for alien signals. But that sort of gave way to the new model where you have sort of dedicated or primarily SETI missions, but they're doing a lot of radio astronomy, right? So, which makes sense because when you think about it, what is SETI doing? It's looking for radio signals where we know that they're not coming from Earth and they're not due to any known natural phenomenon.
Right.
Right? That is a candidate signal, right? We've ruled out terrestrial sources and we've ruled out any known natural sources. So that's also a good way to look for new astronomical phenomena, right? So you're doing radio astronomy when you're doing SETI.
Yeah.
But also they could piggyback a lot of other sort of regular radio astronomy observations on top of, the SETI observations that they're doing. This project is more, so basically went from dedicated SETI to primarily SETI with lots of other radio astronomy to this project, which is primarily other radio astronomy with a little bit of SETI piggybacking on top of it. But still, it's going to be doing some SETI, it's really important to SETI to have very, very sensitive and high resolution radio telescopes because nature can produce massive radio signals, right? You have material crashing into a black hole, black hole eating another star or whatever. That just generates massively powerful signals. If a civilization is like deliberately technologically creating a radio signal, it's not going to be anywhere near as powerful as these natural sources. It's going to be a very weak signal. You can also think about it there'll be like one of two ways. Either they're broadcasting in all directions, like in a sphere, right? In which case it'll be really faint by the time it gets any distance. And so the envelope of space where we might detect that kind of alien source signal is pretty small. Or they could be aiming a directed beam of radio signals at us. So that would be a lot better, right? So we'd be able to detect it from a lot further away, but then we're dependent on them
hitting us.
Shooting it at us. And why would they be doing that? One notion is that, well, maybe if the alien civilization is on a star and from their perspective, the Earth transits the sun, they might see that we have oxygen in our atmosphere and then be blasting a signal at us in case there's anybody here listening. So we're actually focusing on looking at those stars because they might have an easier time detecting us. But even if we did, and remember Seth Shostak told this to us, even if we did detect a candidate signal that survived all attempts at explaining what it is through natural means, and it has some suggestive features of intelligent creation, we still probably couldn't interpret it. We would have to build a dedicated radio telescope to pick it up with enough, precision and resolution to be able to interpret the signal. And that could take years. Could you imagine we might be sitting on a possible alien signal for years, even decades, before we can really know what's in there,
really
what
decode
information
it.
is in there?
Oh my gosh.
Yeah, I kind of feel like I love SETI and I love space travel, but there's this part of me that just doesn't want to know. It's like I don't like if we. I just feel like if we find out that someone's talking to us, I don't know how I'm going to be able to go to work the next day or go to bed. I mean, it's life's stressful enough. There's a part of me that just doesn't want to know.
Well, probably it'll be so far away we don't have to worry about them getting here anytime soon. But also, I think we will adapt to that amazingly fast. Mm-hmm. In 2 weeks it'll be like, there's intelligent life out there that's beaming signals at us. You know what I mean? It'll be
even if they were not nice and they said, "We're coming for you, Earth bastards. We'll see you in 200,000 years." I'd be okay with that.
Found a way to warp space and time to get here.
And Steve, that might be the case for science enthusiasts, and I think there's a percentage of people out there that would take this information in a very bad way.
Yeah. I mean, every kind of reaction would happen. There's 8 billion people on this planet. Anything you could think about, there will be cults around it. There'll be a lot of pseudoscience around it, misinformation. There'll be, a variety of legitimate scientific ways of thinking about it. Absolutely, everything's going to happen. But I think mostly humans are very adaptable, if nothing else. I think we will adapt to that new information remarkably quickly, would be my prediction.
And we'd have a bunch of really awesome segments on this show because of it.
Oh yeah. Yeah, I mean, it'll be. I imagine we would talk about it incessantly, for a long time.
Yeah, I wonder what kind of future resources we would wind up dedicating to further study and further try to grab and enhance that signal and look for other signals like it. I think it would be a paradigm shift. It really would.
Mm-hmm.
I mean, if it required, like $1 trillion, I mean, I don't know if we would do it. Maybe we'd do a little bit over a long period of time, but people would say, we need this money for other things.
Other things. We have someone who's beaming the Encyclopedia Galactica at us. What would take priority over that? We might need to build a space-based radio telescope.
Ooh.
Because then, think about it. You can have radio telescopes that are millions of miles apart. Right, and that would be the functional diameter.
That's a nice wide net right there.
Yeah, and you could also we're pretty much at the limit structurally of radio dishes on Earth. You know what I mean? But in space, with microgravity, they could be a lot bigger. So the sensitivity could be a lot bigger as well, or even just on the moon. With 1/6 gravity, you could build the dishes that are a lot bigger and put them far apart. So, yeah, if that's what's required, we could be talking decades before we build it. And it could be hundreds of billions of dollars or more, or trillions. But damn, it would be worth it. Can you imagine?
And what if we point back to this moment saying the square kilometer array was the tool that started it? It picked up that first signal. We could point back to this moment.
Pick up the first candidate signal that really survives,
There's so much amazing stuff happening in space right now. It's always shocking to me that it doesn't seem to catch on more with the public, and you still hear people say like, "Oh, this is just such a waste of taxpayer money." It's like I wish somehow the news media could amplify some of this stuff even more, because so much stuff's happening.
Mm-hmm. Yeah, I mean, it's out there, but it's just there's so much else competing for it. There's the competition for eyeballs is so intense, in our multimedia, world. But I agree. I mean, obviously, I think science, space exploration, critical thinking should be much more prominent. Imagine how much better the world would be, if
more people were just like us.
If more people were just like us, exactly. No, think about how much time and attention and media, bandwidth is spent on things that are either frivolous or counterproductive, as opposed to something uplifting and educational. And
I think science is, science and art are probably two of the most amazing things that humans are capable of.
Mm-hmm. Yeah.
Don't forget love.
That's the secret ingredient.
If you love correctly, Bob, that is an art form.
All right, Jay, there's some exciting news on Mars. What's going on there?
Uh-oh.
Yeah, this is interesting because it seems to be an update on information that we thought was correct for a while. So Mars has a history of volcanic activity, and in fact, volcanoes have been a significant part of the geologic evolution of the planet. So, much of Mars is covered in volcanic features, things that we're used to seeing on Earth, things like lava flows and lava plains. And so far, the largest volcanoes in our solar system happen to be on Mars, or at least the largest, dead.
Olympus Mons.
Yeah. So we have identified volcanic features going back 3.7 billion years on the surface of Mars. That is a very large percentage of Mars's existence. So looking at the surface of Mars today, though, we see no evidence of plate tectonic activity, right? You know what that is? Like on Earth, the land masses move around over time, and those are plates. Each one of those land masses is we call it a plate, and they do move and they bump into each other, and that's all happening because of geologic activity that's going on underground, the core of the planet. So there used to be tectonic activity on Mars, but it was a long time ago, and it's all but dried up. So other things, though, we also know that Mars has 1% of the atmosphere that the Earth has, and much of the Martian atmosphere was slowly stripped away by the solar winds, which are constantly doing it. And unlike Earth, Mars no longer has a magnetic field to protect its surface and atmosphere. And without volcanic activity, there's no way for that atmosphere to be replenished, right? Because a lot of the gases that an atmosphere is made up of come out of volcanic activity. And also Mars is smaller than Earth, so it's cooling faster. There's lots of factors in why Mars is in the current shape that it's in, meaning that it seems to have a relatively lifeless, unmoving surface. There's not a lot of activity like there is on Earth.
Jay, just one pedantic point.
Sure.
You should say Mars doesn't have a global magnetic field, because
there is a few, right? There is
very weak one in the southern.
There are small localized magnetic fields. Yeah.
Thank you, Steve. Thank you. You're right. There is a little bit of magnetic activity.
Like you have to say non-avian dinosaurs now. You got to say it doesn't have a global magnetic field. Just little pedantic things.
It's good stuff, though. Yeah. Scientists have thought that Mars has no volcanic activity, but recent studies show that these opinions might be changing, and it's legitimate to think that there is. A region on Mars called Elysium Planitia might be geologically active because we now have good evidence of a giant mantle plume found under the surface. A mantle plume,
wow,
right? A mantle plume is not a minor thing. It's a big deal. It's when hot magma comes up from the planet's core. So this magma spikes up through the mantle, which is a pretty significant part of the actual Earth, the material that the planet is made out of. And then that pushes up against the planet's crust. And it's kind of like it's like an umbrella shaped type of thing, right? There's like a feeding line that goes up and then it spreads out and it makes this big plume like shape. We have evidence of a volcanic eruption going back 50,000 years on Mars, but really not that much other evidence, but this isn't a lot of time according to geologic standards. Just keep that in mind. Like 53,000 years, even a couple of million years, not a lot of time when it comes to like things that planets do, right? Because these things, planets exist for an extraordinarily long time.
Oh, yeah.
And geologic features take a very long time to manifest. The human lifespan is nothing compared to, what's going on a planetary scale. That eruption left a deposit of, so the eruption of 53,000 years ago, it left a deposit of volcanic ash, and also the region of Mars is being pushed up from below. So this area is about a mile above the surrounding lands, and using gravity as an indicator, we do gravity readings, we can see that the uplift in land is not just at the surface, but it goes down into the mantle of the planet itself. So these are all significant findings that can lead us to believe that there is volcanic activity still there. Measurements of existing craters on the surface of Mars in this area show that the craters are tilted in a way that indicates that the landmass has moved after the craters were created. And we can timestamp the creation of craters, right? So we could say, hey, this landmass moved in the last, X number of thousands of years, and that is due to volcanic activity. Anytime that Mars has an earthquake, it comes from this region of the planet. All of this evidence indicates that there is a large 4,000 kilometer wide mantle plume there. And we can now, yes.
Does Mars have earthquakes or Marsquakes?
I would say Marsquakes.
Marsquakes, definitely.
So there was a bit of a discussion about that on my in the comments of my blog when I wrote about this.
Did people get upset?
Well, some people get a little upset about it. Yeah. So the question is, when you say earthquake, does the earth part refer to the planet or to dirt?
I always thought to dirt.
So if it refers to dirt, then it's okay to say that you can have an earthquake on Mars.
Yeah.
Right.
Of course.
It doesn't have, but I think both are fine, to be honest with you.
I mean, if we're talking about Mars and I use the word earthquake, I'm talking about Mars.
Yeah, we know.
Yeah.
Would we say earthquake on the moon? Would we say moonquake?
That's the same question.
I've heard moonquakes, yeah.
But I've heard moonquake.
But the point is that some people think it's unnecessary to individualize it to every body. You could just say it's an earthquake.
But it's also more fun, I think. I mean, Marsquake is fun.
Marsquake is more fun.
How often do you get to say Marsquake? Not nearly as often.
But it's this kind of, I can understand why scientists would want that kind of precision in their language. But as a science communicator, I think everybody gets it. You know what I mean?
But saying earthquake on Mars is fine. That's the point.
Okay, thank you. So everything said, we can now conclude that Mars is still geologically active, and this is not insignificant, right? We don't just want to know because it's fun to know. There are reasons why we would like to know that it is geologically active. Now, consider this: when NASA and other space agencies decide where are we going to put down the first, human settlements or bases or whatever that's going to happen on Mars, it's important to know, okay, it's probably not a good idea to build a base on a geologically active area of the planet. Even though an eruption doesn't seem imminent, it could happen at any time. We don't know. You can't predict these things. We can't predict them on Earth with, incredible precision and magnitude and all that stuff. So we got to be careful. It's just smart. Like, let's not put humans in an area where there might be a volcanic eruption. Not a good thing to be around, right? A geologic plume could also be good. It could be a good thing to know where one is. There could be geothermal energy that could be collected and used by people that go there. The heat of the plume, very likely that it would also melt ice found in the regolith of Mars. And if so, there could be groundwater below the surface, like liquid water. And knowing that there's liquid water there has a profound meaning. One, it's if we could get to it and use it. Imagine if we didn't have to bring any water to Mars for future missions. Maybe, of course, the first ones we're going to send them with everything that they need. But if we locate this water, we have a way to get to it, then now we're not flying water from Earth to Mars. That's great. But it also is a cool thing to consider that if there is liquid water and the temperature is not freezing, then maybe there is life on Mars that would exist there, right? If it's anywhere, it's going to be where water is. So that's also, something for science to look into, which is, an incredible thing if we find that. We learned a lot of information from NASA's Mars InSight mission. I don't know if you guys know much about this. This is a rover that was sent to Mars to collect geologic data, and it landed on Mars in November 2018. And guess where they landed it?
Elysium Planitia?
Yes, they landed it there because we had already suspected that there, was geologic activity, and it's been collecting data for over 4 years.
Wow!
It's actually ending its mission this month. Like they're gonna put it into, goodbye sleepy time mode because the solar panels are not collecting as much energy as they need to because of dust and stuff like that. But the thing's been operating for over 4 years. It collected a ton of data, and I would imagine that most of the data that I brought up in this news item came from research that rover had done. Very cool stuff. It's a good thing if Mars is still geologically active. And Steve brought up a really fun thing to talk about. Not likely, but it is interesting to think. Would we be able to manipulate that plume in a way to make it erupt, to take advantage of what the eruption could lead to, which would be possibly more atmospheric gases? Probably not enough to make a big difference on the planet, but possibly, you just don't know. In a different air pressure on Mars could in the future be a very big thing to, people existing on Mars, because right now the air pressure is so low that you need to be in a pressurized suit. But if we were able to increase the atmospheric pressure on Mars, and you imagine people not needing a spacesuit.
Brian, what percentage of an atmosphere do you think you need to survive without a pressure suit?
Oh, okay. Oh, wow.
Minimum.
Yeah. I'm going to say 33%.
Evan, what do you think?
Pressure's pretty important, isn't it? I'll say 67%.
So this is not to breathe. This is just to survive the pressure itself. This doesn't mean that you have enough oxygen or whatever. It's 6%.
Whoa.
That's it. 6%.
I was going to say 20.
So don't say that.
To raise it.
So I would have won.
That was in our book. 6%. So if we could increase Mars's atmosphere, it's a little bit less than 1%. If we could increase it to 6%, that's kind of on the margin. Let's say we went to 10%. That would be enough to walk outside on the surface of Mars without any pressure suit. You would just need a mask for your oxygen, just for the atmosphere, for what you breathe, but you don't need a pressure suit. Isn't that weird?
Would it be uncomfortable?
And hopefully whatever gas is in the atmosphere, it doesn't burn your skin.
Yeah, I mean, it'd probably be mostly CO2, so you couldn't breathe it. You can't breathe in like 10% CO2, but you would have to have like an oxygen tank with a face mask, but you wouldn't need a pressure suit. So it's a lot easier. It would also be a lot easier to have pressurized habitats, right? The more pressure you have outside, the easier it is to pressurize it inside.
Yeah. Yeah, but interacting with a plume though, to mess with a plume to increase the density of the atmosphere. I mean that's that's not going to be happening soon.
Drop some nuclear weapons down there, see what happens.
A little terraforming Mars never hurt anyone.
It's fun to think about, right, Bob? We don't know now, and
it's never going to happen. But yeah, it is fun to think about. Well, everyone, we're going to take a quick break from our show to talk about one of our sponsors this week, BetterHelp.
Hey guys, it's really important to consider your mental health, and BetterHelp is a company that you could use that can actually help you improve your overall mental health. Coming from someone that's been in therapy for most of my adult life, I can tell you that therapy has completely helped me manage my own anxiety issues and stress and literally things that happen in your life that you need to just talk to someone to get off your chest. It's an amazing thing. It's a tool that you should be using to help your life.
BetterHelp is a versatile online therapy that offers not just video or phone, but also live chat-only therapy sessions if that's what you want. You don't have to see anyone on camera if you don't want to. It's much more affordable than in-person therapy. You could be matched with a therapist in under 48 hours.
SGU listeners get 10% off their first month at betterhelp.com/SGU. That's betterhelp.com/SGU.
All right, guys, let's get back to the show. All right, Brian, you have a news item of your own. You're going to tell us about swimming dinosaurs.
Yes, this was very exciting that came through in the last week or so. First, just for my own amusement, I don't know if you guys have done this before, but just like rapid poll, what are your favorite dinosaurs? Steve.
Oh, I'm very partial to a Parasaurolophus, and also I've always liked Triceratops.
Jay?
Yeah, I mean, the classic Triceratops fighting a T-Rex is incredible to me. I think the Triceratops. I know that pterodactyls are not dinosaurs, but
Right.
they're part of my favorites.
Bob?
But it's hard not to love a T-Rex, and I'm trying to remember what the biggest dinosaur that ever lived, whatever that is.
Titanosaurus.
Yeah, the Titanosaurs are up there,
One
but
of
it's
them.
Yeah, maybe Argentinosaurus, one of those big
Yeah.
Titanosaurs.
Yeah,
That's the
yeah.
one, yeah.
Brachiosaurus, maybe?
Evan?
It's one of the big ones, Jay, but that's not the biggest.
Well, certainly as a kid, it was Tyrannosaurus. And then, there was the Brontosaurus controversy for a while,
Yeah,
right?
that was fun.
In which it was kind of, the name was taken away and then reinstituted, if I recall. So I'll give a nod to Brontosaurus as well.
Yeah, cool. Yeah, I was always Ankylosaurus myself. Those were just ridiculous.
They're cool looking.
yeah.
But I also really liked the Spinosaurus once I learned about it in Jurassic Park 3. But and that has a sort of tie into the news item because it's kind of at the center of this kind of interesting debate over the last decade or so about how aquatic dinosaurs were, and there's been some, I think, pretty heavy debate with Spinosaurus about whether they spent a lot of time in the water or whether they just kind of waded in occasionally to snatch a fish. But the newest bit is a new dinosaur they've described with possible evidence for aquatic behavior, which is the Natovenator polydontus, is going to be my best go at it. Which, if Kara was here, she would break that, what's the word, down to swimming hunter with many teeth. And it comes from
polydontus.
Polydontus. Yeah, it comes from the journal. Comes from Communications Biology. And it's entitled "A Non-Avian Dinosaur with a Streamlined Body Exhibits Potential Adaptations for Swimming." And so this little guy was found in Mongolia, and it's a pretty well-preserved fossil with a long neck and a skull that's filled with small little needle-like teeth. They said in the paper that they said, "We think it looks like a Cretaceous cormorant." And you can imagine it kind of like the size of a duck, thereabouts. And if you look at the fossil, like the skull, it really does just look like, Daffy Duck or something. And if you look at there's a reconstruction, an illustration that they did, which I love. Those things are so fun, despite how accurate they may or may not be. But it looks so crazy. I mean, my 8-year-old said, immediately after seeing it, said that's my new favorite dinosaur, because it just looks wild. There's just this weird combination of a duck and a dinosaur. So it's a dromaeosaur, a relative of the velociraptor, and it lived in the late Cretaceous. So that's 68 to 75 million years ago. So it was right at the end. And the big evidence that they're pointing to for why this might be aquatic is that the body and tail were very streamlined, and specifically the ribs were angled toward the tail in a way that's similar to other oceanic birds, which is kind of thought to make it more efficient, can make it a really efficient swimmer and diver to dive for fish. And they thought that maybe it's using its forelimbs to swim around like penguins, actually. So it's really interesting. I think it's important to note that it's not, we're not in like slam dunk territory, I don't think. This is still kind of early, and, it's plausible that they could come up with another reason why their body is shaped that way. And, a lot of news outlets are reporting it as the first swimming dinosaur. And for a lot of reasons, that's sort of a, maybe a bit of an overstatement as science news outlets sometimes do. So it needs more study, but I think it's just sort of another step in this kind of fascinating evolution of this area of dinosaur research, which is, how far did their sort of aquatic lifestyle and habitat possibly go?
Well, why wouldn't there be swimming dinosaurs? We know that
Exactly.
there's a lot of swimming giant reptiles. Like, as Jay said, like pterodactyls are ancient giant reptiles, but not in the dinosaur clade. And the same is true of a lot of the swimming reptiles.
And they're cool looking too.
Yeah, but there's no reason why there couldn't have been dinosaurs that adapted to it. I think it's probably pretty well established now that a lot of the big dinosaurs were wading dinosaurs. That they spent a lot of their time, in lakes or water on the shore, not necessarily swimming, but that's a plausible stepping stone though to swimming, right?
Yep.
Just keep going farther and farther out to get more and more food sources or whatever, or to evade predators or whatever it is you're doing. So it would not be surprising at all if we eventually find a branch of the dinosaur tree that was swimming. Although it's also possible that niche was just already occupied, by the other swimming reptiles. But we'll see. But it's cool. Okay, Evan.
Mm-hmm.
You're going to tell us about ancient environmental DNA.
Yeah, so this dates back millions of years ago. Millions of years. This is a region in northern Greenland, and it was undergoing a period of intense climate change that sent temperatures way up, as much as 10 degrees Celsius higher on average compared to today's temperatures in the region. And during about a 20,000-year period of that intense warmth, sediment built up, and then the climate cooled, froze, and eventually cemented some DNA into the permafrost. And there it lay, undisturbed for 2 million years, until 2006, scientists began drilling samples out of the frozen sediment, collecting delicate and valuable bits of DNA in the process. 2 million-year-old DNA fragments. Yep, they recovered it. And this shattered the previous record of about 1.1 million-year-old DNA, which was, I believe, the DNA of a woolly mammoth from the Siberian tundra. So this about doubles it. As far back as we can grab this DNA. And they used modern analysis technologies in getting this. It really has allowed a team of scientists to reconstruct this ancient landscape. The paper was published in Nature this week. It's titled, A 2 Million-Year-Old Ecosystem in Greenland Uncovered by Environmental DNA. The lead author, Kurt Kager, as best as I can pronounce that, and a team of about 24 scientists participated in this work. And here are the delicate bits that I drilled out from the abstract for your pleasure. We report an ancient environmental DNA record describing the rich plant and animal assemblages of the Cap Copenhagen Formation in North Greenland, dated to around 2 million years ago. An open boreal forest ecosystem with mixed vegetation of poplar, birch, and thuja trees, as well as a variety of Arctic and boreal shrubs and herbs, many of which had not been previously detected at the site from macrofossil and pollen records. The DNA record confirms the presence of hare, that's H-A-R-E, hair and mitochondrial DNA from animals, including mastodons, reindeer, no Rudolph, rodents, and geese, all ancestral to their present-day and late Pleistocene relatives. The presence of marine species, including horseshoe crab and green algae, support a warmer climate than today. The reconstructed ecosystem has no modern analog. This is fascinating. They interviewed geneticist S.K. Willislev of the University of Cambridge in the UK and the University of Copenhagen in Denmark. He says it's a new chapter spanning 1 million extra years of history. It's finally been opened, and for the first time we can look directly at the DNA of a past ecosystem that far back in time. And the problem, of course, when you're looking at old DNA is what? It degrades. It degrades rapidly because of environmental stresses and weather, geological processes, so many things will really tear down that DNA. So if ancient DNA is to survive, it normally is done so when it's inside, say, teeth and bones, where it's relatively protected. But then if you bury that material under the permafrost, it becomes even more so protected. But even more than that, the DNA bound to minerals under the permafrost has proven so far to absolutely be the best means of protecting ancient DNA. So super fascinating.
Yeah, I did a deep dive on this myself too. So a couple of things to point out. They came up with there's a whole science now about the degradation of DNA, right? How DNA degrades over time, how to quantify it, because it may not be obvious. Like how do you put a number on how much the DNA is degraded? They came up with something called the thermal age of the DNA. And as best as I could tell, again, it gets pretty technical, but as best I could tell, if you quantify how much the DNA has degraded, and then we know how fast DNA degrades at a constant temperature of 10 degrees Celsius. This is how old that DNA would be if its degradation were due to spontaneous degradation at 10 degrees C, right? Mm-hmm. So, for example, this DNA that they found in northern Greenland has a thermal age of 2.7 thousand years. So if that DNA were just laying around at 10 degrees C, it would have gotten to that point of degradation after 2.7 thousand years. But of course, it's over 2 million years old, which means that it was degrading 741 times slower than DNA at 10 degrees C. And as you say, that's because of two things mainly. Because one, it's been frozen the whole time, right? So that's critical, the low temperature. Because there's three things that degrade DNA, right? There's physical shear, and so you want geological stability. You don't want the soil to be moving around a lot. There's enzymatic, so that's basically from bacteria. And again, the colder it is, the slower that will be. And it's chemical, right? Just oxidation and things like that. And again, chemical reactions also slow down with temperature. But what also, as you said, what also protected this DNA, so DNA is negatively charged, right?
That's I never knew that before.
I didn't know that either.
That was fascinating. Yeah,
it has a negative charge. That's why when we test DNA, you ever see that where it's like, here's a DNA, they run what's called the gel, right? Where you get all the black lines. Remember seeing that? And then you try to match up. So what they do is they treat the DNA with an enzyme so it breaks down into...
electrophoresis pops to my mind.
Yeah. So basically you're breaking it up into known segments, right? Mm-hmm. Based upon the presence of certain SNPs, basically pieces of sections of the DNA that will get broken by a certain enzyme, and then you run it across a gel in a magnetic field. So the negatively charged DNA will move towards the positive pole.
Neat.
And the bigger the piece, the shorter the distance it goes. The small pieces will go much farther. And so they tend to layer out in these lines along the gel. And the presence and density of those lines essentially tells you what the... about that DNA. So
it's called gel electrophoresis.
Yeah, gel electrophoresis. So if you're just trying to match a sample with another sample, like you take DNA from Evan and you match it with the blood found at a crime scene or whatever, you want to know that it's the same DNA. That's what you do. If the black lines all line up, that means that they were being broken up into the same size pieces. Anyway, that's just a little aside. But there are minerals in the soil that have a positive charge, and they would bind with the negative charge in the DNA. And that would prevent access to the DNA by the enzymes and also reduce the probability of undergoing chemical reactions. So the question is, again, remember, before this study came out, there were papers that said that 1 million years was the absolute limit. It's not just that was the oldest sample. They were arguing that was the limit of DNA.
That was it. That was the breaking point.
In any scenario.
Yeah, in any scenario. Like, oops, no, it's 2 million years. It's twice as long. So the question is, now that we know that sort of mineral, that binding to minerals can have a protective effect on DNA, now what's the ultimate limit? Like, are we going to just say, okay, well, now it's 2 million years, or are we going to say maybe it's 10 million
We need to find more samples.
Maybe it's 20 million years.
Then we start getting into the regions where you're starting to talk about some pretty old species there.
That's right. I mean, obviously the magic number is 65 million years. We get to the dinosaur age.
Oh my gosh.
I don't think that's going to happen, but I I don't think we could say now that it's impossible. I think it goes from impossible to unlikely for DNA to survive that long. There's got to be some kind of environment where it's like super protected.
Do you think like in a frozen cave underground somewhere in the Arctic, something
Well, it'd
like
have to be frozen. So I don't know if
Force
there's some place that's been frozen for 65 million years. I don't know if that's the case. The minerals that were most effective in this sample were clay minerals, specifically for some reason smectite.
Schmecktight.
Schmeck good.
So maybe there's some kind of a clay environment or whatever that could preserve the DNA for like a couple of orders of magnitude longer. I don't know. Maybe it's impossible. We'll see.
It's amazing to think about, though. Yeah.
Yeah, but but definitely I would take any pronouncement about the ultimate age limit of DNA with a grain of salt. Now that they were,
Or a grain of schmecktight.
they were off by such a large amount, not that long ago.
Yeah. Yeah. It's not trivial going from 1.1 million to 2 million.
Yeah.
Boop.
But it's also the whole idea of environmental DNA is awesome. The idea that we can get a snapshot of everything living in an environment is incredible. And of course, we have to mention the fact that they did an environmental DNA sample of Loch Ness.
That's right. To look for evidence of a creature.
Yeah. And what was most significant was what they did not find, which is anything that would match a large reptile-like creature.
Not even close.
What are you saying, Steve?
I think you know, good sir. All right, let's move on. All right, Bob, we got some new data on cat domestication.
Yeah, cats in the news, and this has nothing to do with space or nanotech. So, shocked.
Shocking.
What the hell?
Wow.
Researchers have confirmed a critical hypothesis about the domestication of cats that saw their ancestors transmogrify from wild cats to domesticated pet-like creatures who own many human families throughout the world. So this new study this is from a new study at the University of Missouri. One of the lead scientists is Leslie A. Lyons. Very curious name she's got there, especially given this topic. She's a feline geneticist in the MU College of Veterinary Medicine. Okay, so based on archaeology and art and genetics and studies that we have done, we have a pretty good idea that the household domestication cat, the regular domesticated cat, that domestication process started around, say, 12,000 years ago in the Middle East near the Tigris and Euphrates rivers in an area called the Fertile Crescent.
Yeah.
So it was then that Felis sylvestris libica met a new and revolutionary product of human cultural evolution, a farmer. This was the beginning of our transformation from nomadic hunter-gatherers, of course, to farmers during the agricultural revolution. And agrarian societies eventually will produce many other revolutionary things like grain stores and persistent refuse piles that attract rodents like mice. And the paper describes this as something I liked. It said, and I quote, which led to a synanthropic trinity between humans, rodents, and felids, which synanthropic, never heard that before. That refers to an undomesticated animal that benefits from being near humans. Perfect for what cats were to us 12,000 years ago. Now, the human/cat symbiotic relationship, it seems obvious right now, right? Humans use cats as pest control, and cats use us to feed them and pet them and generally lord over us and think about how much cooler they are than us. But the question is, was this the first domestication event? Or more likely, were there other cat domestication events after that elsewhere? Now, it happens, though. I mean, that's not a silly question. Horses and cattle were separately domesticated at different times and at different places throughout the world. Is that what happened with cats? We're not sure. We didn't know. One study from, I believe, 2007 hinted that perhaps for cats it only happened once. And Leslie Lyons et al. Wanted to see if there was anything to this hint. Is that what really happened? So this latest study then looked at cat DNA from the Fertile Crescent area, plus from Europe, Asia, Africa, and they studied and compared a whopping 200 different genetic markers in their study. So one of the, I'll discuss a couple of these critical DNA markers. One of the markers they studied were microsatellites. Microsatellites are small sections of DNA, as you might have figured out, 1 to 10 nucleotides long. And these are found in the repetitive regions of our DNA. Do you know what they call them if they're greater than 10 nucleotides? They call them mini satellites. Makes sense. I don't think nanosatellites exist, but we're talking about microsatellites. These were important to study because they mutate very quickly, and they tell the researchers about recent cat populations and breeding from the past few hundred years. So that's the resolution. That's what they were looking for, something that was recent, very recent, and a couple hundred years is very, very recent in the scheme of things. The other really important DNA marker that the researchers looked for were single nucleotide polymorphisms, SNPs, which are pronounced SNPs, which we've mentioned on the show before,
including about 20 minutes ago.
Yes. And by the way, in case you were wondering, a single nucleotide polymorphism has, for all intents and purposes, absolutely nothing to do with meatballs. I'm just going to throw that out there. Just saying.
Sure
Why would you even go there, man?
Because I wanted to say meatballs. All right, you happy, Jay? I wanted to throw meatballs in here, and I couldn't think of a way to do it, so that's why I did it.
And you already used transmogrify, so
yes.
that was done. Calvin and Hobbes reference.
Yes, thank you, Evan. Awesome. That's exactly what I was
attention.
thinking. Whenever I use that word, I think of Calvin and Hobbes. All right, so SNPs refer to a substitution of a single nucleotide in a specific position in the genome. We all remember nucleotides, right? The rungs of the DNA ladder have at each end either an A, G, T, or C, adenine, guanine, thymine, cytosine. Okay, so for example, so say you have gene ABC, and it has guanine in a specific place for most people. But a minority, a few people have adenine there instead of guanine, and so that makes it a SNP, and it can make them susceptible to specific diseases. So that's why they're important. Now, researchers like these SNPs because they can clue them in to cat evolutionary history over thousands of years, not a few centuries like the microsatellites, but many thousands of years. So that's why these two different types of DNA markers were important in this study. So then by then studying and comparing these microsatellites and SNPs, the researchers can bring the full evolutionary story of cats into sharper focus, and that's exactly what they did. The conclusion of the study supports this idea that cats were domesticated only once, and people over generations and centuries just took these pets and they spread them throughout the entire world. This area was like the a nucleation site where domesticated cats were basically created for all intents and purposes, and then spread out from there like a cat diaspora throughout the known world. Everywhere they went. That's basically where you could say they came from in a sense. A couple more interesting facts that I thought I wanted to mention. Cats, they're not really technically domesticated in the strictest sense. And I'm going to just mention what Lyons said in her paper. The paper is very good, by the way, fairly readable, but it's easier to read than some of the physics papers I've looked at. She said, we can actually refer to cats as semi-domesticated because if we turn them loose in the wild, they would likely still hunt vermin and be able to survive and mate on their own due to their natural behaviors. Unlike dogs and other domesticated animals, we haven't really changed the behaviors of cats, no surprise there, that much during the domestication process. So cats, once again, prove to be a special animal. And speaking of special, one other fact I'll throw out. Did you know that Lyons showed in a 2021 study that a cat's genomic structure is more similar to humans than almost any other mammal that's not a primate? Where did that come from? I don't know. That's all that was said, and they didn't go into too much detail. But look up her paper from 2021 for more details. Surprising.
Yeah, interesting. All right, so one cat domestication event. That's
12,000 years ago. Yep.
12,000 years ago.
When humans, the agricultural revolution started, we're staying here now, and oh my God, where'd all these rats come from? We need something to kill these rats. Look at these cute little furry. Ouch!
And it's amazing that in 12,000 years we still haven't fully domesticated them. Now, I read somewhere that the definition is that they're not completely dependent on humans for survival. I think that's what you were alluding to there. Whereas,
yeah, I mean, you let them out, you let them outside.
They're fine.
A lot of them can survive and mate. Not a lot of dogs can do that. Our little pampered puppies, and not a lot of them would ever have a chance.
As long as there are enough birds to keep the cats going, because cats will decimate the bird population.
Oh yes, more than decimate.
All right,
maybe
Jay, it's Who's That Noisy time.
All right, guys, last week I played This Noisy. This is the first noise that Bob made after he had sex for the first time.
Why were you there recording it again, Jay?
All right, you guys got any guesses?
It's a porg.
Poor, that's a good guess.
Yeah, right.
Well, a listener named Derek Reethans said, "Hi, Jay. I think This Noisy was a guinea pig squeaking. They make the most silly noises. And why not? Why can't that be a guinea pig? But it's not. It's not the sounds that guinea pigs make." Another listener named Frank Silva wrote in and said, "Aloha from the Big Island of Hawaii, where I'm visiting to watch the Mauna Loa eruption and lava flow. He's been listening for a few years, first time guessing. He says it sounds like air being released from a balloon while pulling the sides of the neck apart. You are absolutely correct that it does sound like that. That is not what it is. And that would have been, I think if I did that legitimately, that would have been a pretty easy guess. But it does sound a lot like it. I'll give it to you." Phil Watson wrote in and said, "This week's noisy sounds like a squeaky toy being mauled by a dog. But I think it's actually the vocalization of one of those funny round frogs. I don't remember what they're called. This is a close guess. You did a good job, Phil. You were getting there, but you weren't all the way there. So This Noisy was identified by a listener named Bradford West, and he said, "Holy crap nuggets, Jay. At first I thought this week's noisy sounded like a now fairly well-known sound of a turtle getting some of the old in-out." It's up to you if you want to leave that in, Steve.
Goes without saying.
So it's totally a desert. He says, "So it's totally a desert rain frog trying to intimidate me." So this is a desert rain frog. So I'm going to ask you, everybody that is capable of going to the internet right now that's listening to the show, go look up a desert rain frog and watch the video of this thing making this noise. It's one of the cutest little animals I've seen probably ever. Take a listen again. That is so freaking cute. It's possible that I've played this one before. I've been doing Who's That Noisy for, I don't know. God, how long has it been, Evan?
Oh, gosh, 7 years now? I think you took over about 6 years ago.
6 or 7 years ago? Yeah, so if I hit one again every once in a while, it's because I
don't mind, Jay. Don't worry
Thanks,
about
Bob. So anyway, good guess. A lot of people guessed correctly this week. A lot of people, identified this animal as one of their favorites. He's really cute. He's like this little, sand-encrusted frog that looks like if you blew too hard next to him, he'd fall over and die. He's like the frailest little dude. Very cool, though. All right, I've got a new noisy for you guys this week. This noisy was sent in by a listener named John Foster. If you think you know what this noisy is, or you heard something cool this week, email me directly, actually, at wtn@theskepticsguide.org. Steve.
Yeah. This is the last show to come out before we go to our Arizona shows.
That's right. Ooh. By the time you listen to this, you will have, if you're listening to this, say, on Saturday or Sunday, basically you're going to be 2 or 3 days before the show in Arizona. If you're in Arizona, come check us out. We're going to be doing 4 different shows, 2 in Phoenix and 2 in Tucson. All the info is on our website, theskepticsguide.org/events. We're super looking forward to seeing all the people that we're going to see there. We're going to have a ton of fun. We're leaving in less than a week.
This is the debut of our new show, the 4-hour live show plus, or private show plus, where we do not only a private recording, we're going to do 2 hours of interaction and games and cool stuff with the people present just for the live audience. So we'll see how it goes, but
a unique experience.
It's going to be fun.
Hey, we're coming up towards the end of the year very quickly, and I'd like to say 2 things. One, for the holidays, if you want to get someone a present, you could think about getting them one of the 2 books that we've written. They're great gifts. They make people very happy. I mean, you'd be amazed at how happy people are when they get these.
Why would you say that, Jay?
Why?
Yeah. Why get one of them? Get both of them, damn
Both
it.
of them, yeah.
Absolutely.
You could also get someone an SGU swag item, a T-shirt, a Christmas ornament, a bag. There's lots of things on there. You can go to our store. Just go to our website to find the link for our store. They make good little stocking stuffers if you want to get some SGU fans some swag that they would like to have. And then finally, if you enjoy the show, if you enjoyed the work that we've been doing on this show, if you're a regular listener, consider becoming a patron to help us continue doing what we do. It takes a lot of people and a lot of time and a lot of energy to keep doing what we do, and we appreciate all the support that we get, like people like Brian, who is on the show this week because he likes to give. Thank you, Brian. We appreciate it. But please do consider becoming a patron of ours. It helps. It keeps everything moving in the direction that we need to keep putting the show out. And you could become one of the people that supports something that you believe in. You can go to patreon.com/Skeptics Guide.
Well, everyone, we're going to take a quick break from our show to talk about one of our sponsors this week, ExpressVPN.
Everybody should know this by now. We live in a time where everything that we're doing online is being tracked. And that information is being sold to different companies. And, this is why when you search for something on a website, another website might show you an ad for that, right? That's because you're being tracked. I use ExpressVPN to stop this from happening because I don't want to be tracked. I don't want people to know what I'm looking at.
Every time you connect to ExpressVPN, you get a random IP address shared by many other ExpressVPN customers. That makes it harder for third parties to identify you or harvest your data. Best of all, ExpressVPN is super easy to use. No matter what device you're on, phone, laptop, or smart TV, all you have to do is tap one button for instant protection.
So if you really want to go incognito and protect your privacy, secure yourself with the #1 rated VPN. Visit expressvpn.com/SGU and get 3 months extra for free. That's expressvpn.com/SGU. Go to expressvpn.com/SGU to learn more.
All right, guys, let's get back to the show. Evan, you're going to do a segment on potent quotables.
Yeah, we're going to play the Potent Quotables game. Last one of the year. And of course, I'm going to say I'm going to give you some quotes from people whom we should be familiar with. And you'll have a choice, A, B, or C, and you'll have to decide which of those 3 people said each of these quotes. There's 5 quotes in total. You guys have played this before. Brian, Steve, Jay, and Bob are our contestants this week, but go ahead and play along at home as well, and feel free to let us know how you did. Are you guys ready?
Always. I live in a perpetual state of readiness.
Absolutely you do. Quote number 1. I'm sure you've seen the pictures all over the internet of people who have had these shots, and now they're magnetized. Who said that? Was it A, Gwyneth Paltrow, B, Sherry Tenpenny, or C, Donald Trump? And Brian, as our guest, you are going to guess first.
Oh, boy. God, that rang such a bell when it came on, and then the 3 options just completely whacked me. I mean, yeah.
It's sad because it could be any of them.
Because it's like, it does feel like something Trump said, but then he also, if he's talking about those shots, he created those shots and was, I don't think it was, I shouldn't say what I don't think it was. All right, I'm going to go with B.
Sherry Tenpenny, okay. Bob?
Don't remember Trump saying that. And I don't think Gwyneth said it, so by default I have to go with Tenpenny.
Jay?
GWB.
I'm going to go. Yeah, it is GWB, but I'm going to go with Brian.
And Steve.
Yeah, when you were first reading the names, you said Gwyneth Paltrow. I'm like, yeah, she definitely said it. Then you said Tenpenny. I'm like, yeah, no, she said it. And I don't think Donald Trump said it. So I'm going to say Tenpenny.
And all the contestants are correct. It was Sherry Tenpenny in a testimony to, I believe it was in Ohio to
I could picture her, and it didn't look like Gwyneth or Trump, so it had to be Tenpenny.
Good job. All right, everyone got that one right. Moving on, second quote. I can say with absolute certainty, I do not cheat. I am not a magician. Who said that? Was it A, Uri Geller, B, James von Prague, or C, John Edwards? And Bob, we're going to start with you.
let's go with Prague.
Okay. And Jay?
I'm going to say that it was Uri Geller. Sounds like
Steve?
something that he would say.
Yeah, it could be any of them, but I do think that's an Uri Geller quote.
And Brian?
Yeah, I'm gonna take the coward's way out and go with A. Uri Geller.
And anyone who said James von Prague is incorrect. Sorry, Bob. It was, in fact, A. Uri Geller who said that.
Yeah, I thought that was too obvious, but
Don't worry, they get a little harder as we move along. Here's the third one. I love Scientology. I've been involved for 38 years, and I don't think I'd be here without it, because I've had a lot of losses and different negative things that have happened over the years, and it really got me through brilliantly. Who said that? Was it A, Tom Cruise, B, Kirstie Alley, or C, John Travolta? Jay, we're going to start with you.
I mean, I'm going to say Kirstie Alley just because she recently died and has been in the news.
Okay. Steve?
Yeah, that was exactly my reasoning as well. I think it's Kirstie Alley. I know she's a long-time Scientologist. I don't think that Tom Cruise has been for that long. Travolta, maybe, but I think Kirstie Alley would be my guess.
Okay. Brian?
Yeah, that's where I was leaning. I mean, it's Tom Cruise. It has a certain way that he talks, and that just doesn't sound like it. And I could see Travolta saying it, but I was also defaulting to Kirstie Alley.
That's a good reasoning, Brian, because Cruise would have been jumping up and down on a couch screaming it as opposed to sort of calmly exclaiming it. And Bob?
Lieutenant Savick.
So everyone's going with Kirstie Alley? And it was, in fact, John Travolta. Yeah, kind of did. Gotcha. That. Yeah, I used... and sad. I used the recent death
You
of Kirstie Alley.
exploited the death of Kirstie Alley.
Totally.
Scurrilous.
Totally. And clearly Scientology did nothing for her to keep her alive.
You see, Evan, I gave you too much credit for that.
That's got to be the most evil thing you've ever done, man.
Oh, thanks, Jay.
That's true. If that is the most evil thing you ever did, that is a compliment.
It is a total compliment. All right, fourth one. The best way to detoxify is to stop putting toxic things into the body and depend upon its own mechanisms. Who said that? Was it A, Gwyneth Paltrow, B, Joseph Mercola, or C, Andrew Weil? We're going to start with Steve.
You know, that can be interpreted in a couple of ways. So that sounds more like the fine line that Andrew Weil walks, because the other two guys, they want to sell you crap to detoxify you, not just don't consume toxins and depend upon your body's own detoxification. So I'll say Weil.
Okay. Brian?
I'm not as familiar with Weil. I think just to be different, I'm going to go with Mercola.
Okay. Bob?
Yeah, I agree with Weil. I want to hear what his follow-up statement was after that.
And Jay?
I'm going to go with Brian again.
So you're going to say Joseph Mercola. All right. Steve and Bob, you both said Andrew Weil, and Steve and Bob are correct. That was Andrew Weil.
Is he still a thing, man? I haven't heard of him in years.
Yeah, well, you know, some of us never forget. We are the vanguard of, of lots of crazy stuff out
He's still
there.
around.
Yeah, Dave's definitely still around. And unfortunately, I don't have the follow-up to that. I'll have to research it and maybe get back to you another time on that, Bob, and let you know. It was just a one-off sentence quote. All right, folks, here's the score. Brian, you've got 2. Bob, you've got 2. Jay, you've got 2. Steve has 3. So, and there's no tiebreaker. So, Brian, Bob, Jay, this is your chance to catch up with Steve, as long as you can keep him out of this final quote. Here we go. I've never really wanted to go to Japan, simply because I don't like eating fish. And I know that's very popular out there in Africa. Was that A, Kanye West, B, Britney Spears, or C, Justin Bieber? Oh, the triple groan from Brian. All right, Brian, you get to start.
Okay. Yeah, well, I mean, I have to eliminate Justin Bieber from that just because I believe he's smarter than that. I really do.
Fair enough.
Man. And I'm sort of going to go for this kind of reverse Kirstie Alley thing. Like, I think Kanye is maybe too much in the news. Mm-hmm. So I'm going to say that was a Britney Spears quote.
Okay. Bob?
I'm going with Biebs.
Okay. With Justin Bieber, right?
Yep.
Jay?
I got to go with Kanye.
Ooh, we're all over the place, Steve. Bring it home.
Britney Spears. I mean, I would hope that Kanye knows where his ancestors come from, and although I know that's giving him a lot of credit, and I don't think that Bieber. I mean, you know, whatever his reputation is, I have no reason to think that he's dumb. So, you know, Spears really by default.
Okay, Spears by default. And that was Britney Spears. Yes, it was. So Brian and Steve got it correct on the fifth one. But Steve, you got 4 out of 5 this game, so you are the winner this time. Congratulations.
Thank
Good
you.
job, Steve.
Well done. Well done.
Well done, sir.
All right,
You all
thanks,
did quite
Evan.
well.
That was fun.
Thank you.
That was a good one.
Good.
You came
Good,
up with the good, the people who could have said it, all plausible.
Yeah.
It was
Absolutely, which is scary
Yeah.
in a lot of ways.
tricky. All right. We're going to do one email. The emailer begins, so can't seem to find a good explanation. Feels like you might have a good answer. Was listening to this week's show. I am excited by Artemis and the mission, but for a rocket launching over 50 years since Saturn, it seems we are talking 15% more power, and the payload to the moon may be 10% more. With CAD/CAM, computerized systems, material science, etc., feels like this is the least impressive improvement for any technology over the last 50 years I can think of. Even cars are far better, and they added way more safety equipment. Is this really that impressive, or just nice since it is a commitment to science? All right, so I had to include this question because it so overlaps with our book, right? Because it's talking about how much technological improvement we should have expected over the last 50 years in rocket technology. So I would point out, it depends on what feature you're looking at. I mean, I think it's safe to say that our rockets are more sophisticated today than they were 50 years ago. But if you're looking at one particular parameter, the payload, let me back up and give an example of what I think is the least amount of technological improvement we've made over the last 50 years. And that is commercial airliner travel times. As we point out in the book, when we were single digits, like we were 6, 7, 8 years old, we visited California. We had relatives out in California. And the trip from New York to LA took about 6 hours. The last time I went to LA, 50 years later, the trip took about 6 hours. There's been literally no improvement in commercial jet travel times. And that's because jets are running up against the laws of physics, right? They're flying at the optimal speed below the sound barrier to preserve fuel and to be efficient, right? And breaking through the sound barrier would be a whole new technological thing. So that's it. There's no change. So let's look at rocket science. What physical limits might they be running up against? Well, it's basically, guys, you know what I'm going to say, right? The rocket equation.
Rocket equation.
Yeah, the bigger you are, the more fuel you have to carry, then you have to carry more fuel to carry that fuel, et cetera, et cetera. That curve goes up really steeply. And we're pretty much getting close to the limit, with these giant rockets that we have. We can't just keep building them bigger, There is a limit there. So, squeezing out an extra 15% is actually quite the advancement when you think about it.
Plus, we haven't been making moon rockets since the 60s.
Yeah.
We basically had to reinvent the wheel in a lot of ways for Artemis compared to Saturn V.
Yeah, we've been focusing on low Earth orbit, basically, rockets, and we've made obviously a lot of advances there, like with SpaceX and the reusable boosters. But there have been advances in terms of handling the rocket fuel and efficiency, et cetera, and safety and reliability. But if you're looking at just payload, we're pretty much running up against the limits of the fuel. Not only that, it's not like there's some magic fuel out there. Actually the best specific impulse of any rocket fuel is hydrogen. We already have the best fuel you can possibly have when it comes to payload and power, right? In terms of specific impulse. So just because that specific impulse is basically the amount of ultimate thrust you're going to get for the weight of the fuel, and nothing's better than hydrogen because it's the lightest element. You know what I mean? It's just
it doesn't get lighter than that.
No, you can't get lighter than hydrogen. And so we're there. The other thing, when you think about material science, as we pointed out many times, steel is still king, you know?
Yep.
Even Musk, when he was trying to figure out what should he build his starship out of, he landed on an alloy of steel as the best thing to make it out of. Not necessarily the ultimate best, but it was the best for the money, you know what I mean, in terms of the most cost effective,
sure.
But it was still perfectly fine. You can get an alloy of steel that is perfectly serviceable as a material to build your rocket out of, and it's very cost effective because we have a massive steel industry on this planet. I think, some sort of carbon...
Composite?
Yeah. Some kind of carbon composite might have been stronger, lighter, or you could make it out of titanium, which is stronger, lighter than steel. But just not cost effective. Yeah, he wanted to build hundreds of them, so it wasn't going to be cost effective. So anyway, it's not surprising at all that, payload and power of these rockets are pretty close to the limit, and we're only going to have really incremental advances in that one feature. I think focusing on getting the rockets to be more reliable, cost-effective, reusable is really where the advances are going to be. Right?
Yeah, you can't beat the thrust of a chemical rocket, and the hugest problem with it is that you just need so much, and you can't thrust for long, but it can thrust for plenty long enough to get out of the atmosphere, and we're going to be using it for generations. Mm-hmm. It's going to take a dramatic upheaval in technology to go beyond launching using chemical rockets.
Yeah, there's really nothing in the pipeline. I mean, we thought about this as a thought experiment when we were doing this part of our book, and it's like, yeah, what other than chemical rockets has the thrust that you're going to need, to get out of our gravity well of Earth? There really isn't anything. The only thing I could really come up with is if you put a fusion powered rocket on a jet plane, like piggyback it, get it as high and fast as you can, and then launch from there. Yeah. But even then, I don't know if that's going to have the thrust to get you up to speed fast enough. Yeah,
I read some scenarios where using nuclear rockets for a land launch into space is potentially feasible, but the radiation release is not
massive,
good. Yeah, and it's problematic. I mean, and not necessarily completely and utterly unavoidable, but just very, very problematic. So that's not going to happen anytime soon, assuming it's even practical.
Yeah.
Chemical rockets for launching into space, unfortunately, for quite some time.
For the foreseeable future.
For human launch, anyway.
Yeah. Off Earth is the other thing I have to say. Yeah, absolutely. Okay, guys, let's move on with science or fiction.
It's time for science or fiction.
Each week I come up with 3 science news items or facts, 2 real and 1 fake. And then I ask my panel of skeptics to tell me which one is the fake. Brian, you didn't tell us on the show what your profession is.
Yeah, so I'm a video editor and producer at the National Geographic Society. And working for a conservation group called Pristine Seas that's focused on ocean conservation.
Awesome.
So basically I'm praying that the topic is not about the ocean.
Yeah.
I really don't need to be embarrassed right now.
So you have no medical training at all?
No.
All right. There is a theme this week. The theme is rare, weird diseases. These are diseases that you hopefully have never heard of that are kind of weird. Okay, 2 of them are real, 1 is fake. Here we go. Item number 1. Translucent fibrodysplasia is a genetic connective tissue disease in which the skin and connective tissue become progressively translucent over time. In advanced cases, muscle can be seen through the skin. Item number 2, Alice in Wonderland syndrome includes an altered sense of body image where one's own body parts seem disproportionately large, and may also include a sense of time passing either very slowly or rapidly. And item number 3, autobrewery syndrome results from bacteria or fungi in the GI system fermenting food into alcohol, causing persistent intoxication. All right, Brian, as our guest, you get to go first.
Okay, these are very interesting and cool as advertised. I guess not fun for the people that may or may not have them. Translucent fibrodysplasia. Yeah, it sounds fairly plausible. It feels like something that they would, use as a starter for some kind of supervillain in a mutant movie or something, but it seems plausible. The one that's really tripping me up is this Alice in Wonderland syndrome. I just can't get over the fact that there's sort of two aspects of it that seem to both be relating back to Alice in Wonderland. That in itself just seems, because they seem disconnected. I mean, obviously they both have a sense of, disconnection or exaggeration of your senses, I guess. But that one's tripping me up. And then autobrewery syndrome, again, the name, it's like, are people just having a laugh? Like, this is, oh man. But that also, I think that one seems, you know what, I'm going to go with the autobrewery syndrome. I think 2 is crazy. Alice in Wonderland is crazy enough to be true. And something about the autobrewery, it just seems almost too silly.
That's the fiction.
Yeah, autobrewery is the fiction.
All right. Bob?
All right, let's see. Translucent fibrodysplasia. I think I knew somebody with this. Long time ago in school. Steve, you might remember him as well. I'm not it kind of seems similar, although not identical. But that's just not as bizarre as the other ones. The Alice in Wonderland one. I think I would have heard of that, especially the time passing slowly or more rapidly. But the one that makes, I think, the least sense, I think Brian hit it. The autobrewery on multiple levels, this doesn't seem quite right. So I'm going to do another GWB.
Okay, Evan.
Oh, I have a feeling I'm going to follow this pattern. I think the Alice in Wonderland syndrome, it's so kind of corny that this one has to be true in a way, right? There's always one that's like beyond ridiculous that winds up being true among these kinds of things. And that is some wild stuff going on there with that one. But the autobrewery syndrome, first of all, the name's a little too contrived. I mean, it doesn't have to be brew seems like more of a beer specific kind of term as opposed to alcohol in general. And, causing persistent intoxication. I thought there were systems in the body that prevent that from I don't know how that would be. I can't see how that would physiologically be happening on a constant basis with the body. It has various mechanisms to prevent that very thing, I think, from happening. So that's why that one, to me, is the fiction.
And Jay.
The Alice in Wonderland syndrome, the idea here that people could have a weird idea about their body parts and everything. I mean, I think that any mechanism that the brain has that works can go wrong. And I know after, because I'm related to a neurologist and have talked neurology with Steve for the last, 30 years. That doesn't seem weird to me. I think, the Alice in Wonderland thing is actually like, something's gone wrong with the brain and they're not detecting their body parts the correct way. That's the one I think is the most obviously correct. And then I go to the autobrewery syndrome. I've had a couple of GI things happen to me in my 50 plus years on this planet where I wouldn't be surprised that something like that could happen. It doesn't mean that I don't know how permanent it is or what it is, but we have such a huge amount of bacteria and there's a ton of bacteria out in the world and you get the wrong kind of bacteria in there and it does something wacky with your digestive system. I could see that happening. So I don't know anything about translucent fibrodysplasia. I remember what Bob was saying about someone in school growing up that had some type of skin disorder, but I don't know, any details. I don't know anything about it. I just think it sounds It sounds like something I would have heard about, unless it's unbelievably rare. So I think that's the fake.
Okay. Jay struck out on his own.
Oh, boy.
So you guys all agree on number 2. So we'll start there. Alice in Wonderland syndrome, AIWS, includes an altered sense of body image, where one's own body parts seem disproportionately large, and may also include a sense of time passing either very slowly or rapidly. You guys all think this one is science, and this one is science. This is science.
Okay.
Yep, this exists.
You got me there for a second.
Smack us with the fiction.
And yeah, it's whimsically called Alice in Wonderland syndrome. The primary feature is it is all tied together because it's altered perception, right? And it's different types of perception too. There are different ways this can manifest, but it could be, they could have hallucinations, they can have auditory, tactile perception problems. But the most common one is distorted body part images, and it's usually they perceive them as being larger, although they can perceive them as being smaller in some cases, but it's usually larger. And they also perceive the passage of time can also be massively warped. They think everything is going in slow motion, or time could seem to zip by. But it's all perceptual processing. That's the common thread through all of this.
And is there one specific part of the brain that sort of controls for that, Steve, or is it?
So yes and no. I mean, this is not just one little piece of the brain. It's networks in the brain that are doing it, but it is in the sensory association cortex. Interestingly, like what causes this? What causes this to happen? It can be caused by either tumors or seizures, and migraines. It actually has commonly occurs with migraine, and the treatment of it is to use migraine prophylaxis. You just give drugs that we use to treat migraines, and it can help it. Sometimes, so the known causes are migraines, temporal lobe epilepsy, brain tumors, psychoactive drugs, and Epstein-Barr virus infections in the brain. Interesting. Okay, I guess we'll go back to number 1. Translucent fibrodysplasia is a genetic connective tissue disease in which the skin and connective tissue become progressively translucent over time. In advanced cases, muscle can be seen through the skin. Jay, you think this one is the fiction. Everyone else thinks this one is science. And this one is the fiction. Good job, Jay.
Jay.
Nice solo win by Jay.
No way.
I just completely made this up.
That's a good one.
My thought process was, I'm basically having to invent a fake disease, right? A weird fake disease. So I'm like, maybe, what could the disease be? It's really hard when you think about it, because pretty much anything that can go wrong does, right? And so it's hard to think of a plausible disease that doesn't exist at all. So I thought, what if the skin turned a weird color, right? And that was the disease. It turns out there are diseases that turn the skin green, blue, red, orange, yellow, black, white, and gray, and purple,
what about
and
hues?
pink. I couldn't come up with one color of those colors, that didn't have a disease associated with it, or at least like a pink rash or purple rash or whatever. So I went with translucent. That's where I got to that. And I could not find that exists anywhere in reality. So,
well, if it one day does exist, then
there you go.
Then we can correct this science or fiction.
There you go.
Right. That's a fantastic name. You did a really good job. That sounds so
totally
believable.
plausible,
Of all
totally
this.
plausible.
That was the hook. The name was the hook. Yeah.
Yep. Damn.
But that's, my medical background. It's easy to make up fake medical terminology. All right, that means that auto-brewery syndrome results from bacteria or fungi in the GI system fermenting food into alcohol, causing persistent intoxication, is science. I almost didn't include this one because I thought it was too plausible. Why wouldn't this not happen? Bacteria, fungi, they ferment sugar into alcohol. Why does that not happen in our intestines, And
then doesn't the liver fix that?
And then the liver detoxifies it. That's why you're not permanently drunk, but you're constantly making alcohol out of the sugar in your gut, right? As long as you have it there.
But you're saying it causes persistent intoxication.
Yeah. I mean, as long as you eat. Now, you can fix it by having a special diet that doesn't include any food that the bacteria will metabolize, will ferment. So typically you have to completely exclude simple sugars from your diet. and certain other kinds
Not
of
easy.
carbohydrates. Yeah, not easy. But if you did that, then it fixes it. But it's remarkably hard to change the bacterial flora
Remarkable.
of your GI system. That's the latest thing, huh, Bob?
Yeah.
So, but yeah, I thought this one was eminently plausible, but weird. And the name is why I used it. The auto
Yeah, I
brewery
couldn't
system.
get past that.
But that's what it's called. That is what it's called. There's usually whimsical names like that for all kinds of these bizarre diseases. Yeah.
Incorrectly
Auto
named.
brewery syndrome. Come
Brewery.
on.
That has to do with beer.
I can imagine people imagining they could create a new craft beer from there.
Just have to isolate whatever it is in my intestines that are getting me hammered all the time.
Wow.
Yeah, it's like people insist they haven't had any alcohol to drink, and yet they're drunk and they have a blood alcohol level. Yeah, and then you got to eliminate all sugar from your diet. Good luck with that. All right, good job, Jay. I always love it when people go out on their own and win.
You can't win if you don't play, Steve.
That's right. You're right, brother. All right, Evan, give us a quote.
Scientific results are always preliminary. No good scientist will believe that they have offered the last word on a given subject. Brian Cox. If I have to tell you who Brian Cox is, look him up. You know him.
Look him up.
Brian.
Yeah. That's good, but that's, again, one of those quotes that it's true as far as it goes, but there's a lot of discussion that you can have around that, because that doesn't mean that we don't know something to such a degree that we can't act upon it, right? So there's preliminary, then there's preliminary, right? Like,
yes.
This might be... any scientific conclusion is always subject to revision when further evidence comes in, but that doesn't mean we can't act as if it's true, because we have overwhelming evidence. Otherwise, how could you practice medicine, right? Or do anything, or send.
But is it appropriate for a scientist to declare it such?
We say, it depends on how careful you are with your verbiage, right? We could say that this is, rock solid or well established or established beyond reasonable doubt, or, we can take this as a scientific given. But that doesn't mean it's the last word, because we can always get a deeper understanding of reality that changes it. But usually that doesn't make it wrong. It just makes it incomplete, right? Like, take something obvious. The Earth is a sphere. That's never going to be proven wrong. It's just going to be refined, right? Okay, it's a spheroid. It's an oblate spheroid, It's a lopsided oblate spheroid, whatever. But it's still a sphere, right?
Right.
It's like even Newtonian mechanics wasn't rendered wrong by relativity, just, incomplete.
Incomplete.
Yeah, it's right as long as you're not traveling at relativistic speeds or parked next to a black hole or something. That's an important caveat. Like, you know what I mean? Like, DNA is the molecule of inheritance. No later discovery is ever going to change that conclusion. We can act as if that's 100% rock solid. But that doesn't mean that there aren't nuances that we discover, like epigenetics and other things that modify it, etc. But just the basic fact that, like, DNA is the primary molecule of inheritance is so well established. I mean, nothing's going to overturn that. Yeah. So as long as there's a lot of context to that quote. And so that's a kind of a complicated idea to try to put into one pithy quote. It's, again, true as far as it goes, but it requires a lot of discussion to really put it into scientific context. You know what I'm saying?
Mm-hmm. Yep. We still love Brian Cox, though.
Yeah. Brian Cox is awesome. Yeah.
Good science.
Again, you're like, what did he say after that? Like, that's always that's something else I would want to know. Well, Brian, thank you for joining us on this episode. It was a lot of fun.
Yeah, man.
Yeah. No, thanks for having me. It was a blast.
Appreciate it, Brian.
And from what you're saying, you're going to clean up all the plastic in the oceans, right? That's what you're doing.
We're focused on the marine protected area part of the problem, but plastics is it's just such a looming awful threat.
Totally.
But yeah, we're working on it.
All right. Well, good luck with that. All right. Well, thank you all for joining me this week.
You got it, Steve?
Sure, man.
Thanks, Steve.
I'm looking forward to seeing the rest of you and Kara and George and Ian in Arizona and all of our Arizona listeners. It should be a fun trip. But until next week, This is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.